Welcome back to the Explainer. So we're calling this one the Master's Crucible. If you've been following our deep dive into the Luterno 375 jacking system, you know we've covered some incredibly dense ground. But today is a little different. This Explainer is your final competency assessment, designed specifically for offshore engineers and technicians. And it's not a passive experience. I'm going to challenge you to demonstrate your mastery through some rigorous knowledge questions and 4 real-world scenario exercises. Your job is to pause this explainer, think critically, and lock in your answers before I reveal them. No reference materials, just you and your knowledge. You ready? Let's do this.
Here is the agenda for today's Crucible. Core knowledge on system specs, core knowledge on brakes, applied scenarios for troubleshooting, applied scenarios for emergencies, and finally, course completion. Let's get right into it. Section 1, Core Knowledge, System Specs.
All right, here's your very first challenge. Think about the architecture of the rig. How many total jacking motors are on a Super 116 E-Class rig, and exactly how do we derive that number? Go ahead, pause the explainer right now, do the mental math, and lock in your answer. Got it? If you calculated exactly 60 motors, you absolutely nailed it. But as any offshore engineer knows, just memorizing the number isn't enough. You really have to understand the physical layout to troubleshoot effectively. It's all about that physical layout. Check this out. You have 3 structural legs on the vessel. Each of those legs has 4 cords. And operating on each cord, you have 5 individual drivetrains. So 3 times 4 times 5 gives us that full synchronized array of 60 motors. Simple, right? Okay, let's test your memory on mechanical advantage. It obviously takes an astronomical amount of torque to lift thousands of tons of steel out of the ocean. So what is the total gear ratio from the motor shaft to the climbing pinion? And what are the specific gear stages? Pause again and lock it in. Did you remember the decimal? That colossal total gear ratio is exactly 2,082.67 to 1. That right there is the massive mechanical multiplier letting those electric motors actually physically jack the hull up the legs. But how do we get to that massive number? It breaks down into specific stages. We've got the 1-pitch gear set, the half-pitch gear set, and finally the quarter-pitch climbing pinion. The really crucial takeaway here, though, is the no-4 gearbox. It alone accounts for a staggering 69.33 to 1 reduction ratio before it even hits the external gears.
Moving right along to Section 2, Core Knowledge, Brakes.
So imagine the absolute worst-case scenario while jacking the hull. The entire rig just goes black. Total electrical power loss. Pause the explainer and tell me exactly what happens mechanically inside the braking system. The absolute key phrase here is spring applied, electromagnetically released. That is your fail-safe principle. When the power drops, the electromagnet instantly de-energizes. The moment that happens, heavy mechanical springs slam down, applying full clamping force across all 60 motors automatically at the exact same time. 0 human intervention needed. Now, since this life-saving system relies completely on physical friction and mechanical travel, calibration is everything. So what is the correct operational brake air gap? And crucially, what is the danger if maintenance gets sloppy and that gap gets too wide? Lock in your exact measurements. The ideal gap is 0.070 inches, or 1.8 millimeters. If that gap creeps past 0.090 inches, you are in real trouble. The pressure plate now has too much physical distance to travel. That means response time goes up, and much worse, your braking torque drops critically. The springs literally can't clamp hard enough if they're forced to stretch too far.
Next up, Section 3, Applied Scenarios, Troubleshooting.
All right, time for a real-world scenario on the deck. You're raising the hull. Suddenly, all 5 motors on the bow leg's cord C show overload trips at the exact same time. Plus, the bow leg kilowatt draw is running 15% high. What is your immediate action plan? Pause and decide. If your first thought was just reset the breakers and try again, you would have caused some major damage. 5 simultaneous trips on a single cord is a massive red flag for a common cause fault. It's not electrical, it's physical binding. You must stop jacking immediately. You're likely looking at a damaged guide bearing or physical obstruction on the rack. You absolutely have to inspect and clear cord C before doing anything else.
Okay, Section 4, Applied Scenarios, Emergencies.
Picture this. The hull is 8 feet off the water. Suddenly, the rig starts tilting, with one leg 2 feet lower than the rest. And right then, the jacking console goes completely dark. you're blind, and the rig is dangerously out of balance. Pause the explainer. What is your absolute first priority?
It's kind of a trick question, because whether you try hooking up a remote laptop via Ethernet for monitoring or running blindly off the local switchboard, neither of those is the priority. Your one and only priority is to re-level the low leg immediately, stabilize the vessel first, and worry about troubleshooting the dead screen second.
Let's tackle one more high-pressure situation. The GFR, or ground fault relay warning light, comes on for the port leg. A severe storm is rolling in, weather is deteriorating incredibly fast, and you've got maybe a 2-hour window. A ground fault cannot be overridden. What do? Pause and define your exact steps.
You obviously can't ignore it, but you also don't have time to test every single wire. You have to systematically isolate it. Step 1. Get to the junction box. Step 2. Disconnect the 20 motor leads in groups. Step 3. Watch for the exact moment the GFR light clears to pinpoint the faulty circuit. And Step 4. Isolate that single motor and safely jack the rig with the remaining 19. That's how you beat the storm.
And finally, Section 5, Course Completion. Take a breath. If you nailed those questions, you have officially mastered some incredibly dense concepts for the LeTourneau 375. We're talking rock and pinion mechanics, that huge 2,082-to-1 ratio, fail-safe brakes, mandatory pre-jacking checks, and even PLC diagnostics. But remember, this explainer is just the theory. You still have to complete your practical skills checklist out there on the actual physical equipment. Which brings us to the final takeaway. As you step onto the steel deck of the rig, your golden rule is this: always consult your vessel-specific IOM manual before performing any work. True expertise isn't about memorizing everything perfectly. It's about having the discipline to check the manual first. But when the power cuts out, a storm is raging, and you literally can't find that manual, will the core principles you locked in today be enough to save your rig? Thanks for joining me for this explainer, and I'll see you next time.